Oh, wait, you're listening?
Okay.
All right.
Okay.
All right.
You're
Listening
to Radiolab.
Radiolab.
From
WNYC.
See?
Yeah.
One of the reasons that I come to you is maybe 10 or 15 years ago, I read a popular science book. I'm not even going to say the title because I think that it was like somewhat controversial afterwards. And I remember this fact, and I think since I read it, I have wondered if it was true. And I've also told everybody this fact. So this is like my live fact check, which is I read that as you go through your menstrual cycle, the size or shape or makeup of your brain changes. And I remember reading that and thinking, wait, my brain actually physically is changing? Is that true?
Okay. There's so much to unpack here.
Hey, I'm Molly Webster. This is Radiolab. And today,
I can go real far back.
we're going hard on a question that I have been thinking about for years.
Totally.
It's funny, as I've been thinking about this topic, everyone's like, honestly, you should just talk to Emily.
Oh.
Like, Emily is a neuroscientist, a neuroendocrinologist to be precise, and she is on one of the teams that has been struggling to understand how hormones affect the brain.
Because we had these glimpses, these little flickers of what it could be doing. But to watch the full cinematic view of how this is unfolding, that was a breakthrough.
Very recently, Emily's lab came up with an experiment that's so precise, so daring, it allowed them to pin down what hormones can do to our brains. And here's the thing, even though the story starts with menstrual cycles, it very quickly gets to the fact that women, men, whoever, we are all at the mercy of a crashing, swelling wash of chemicals inside of us. The chemicals we call hormones.
So when we say a hormone, maybe we could just define our terms. Like when we say
please.
a hormone, that's a chemical messenger. It's a chemical that is released from an endocrine gland like testes or ovaries. You have adrenal glands sitting on top of your kidneys. You have a thyroid gland. And then once they start producing hormones, those hormones use your circulatory system, your blood supply as their superhighway. Right? They hit, almost every cell in the body. And that's, when you think about why do we even have hormones? Like, why is that a thing?
Just to make it complicated.
Just to make it complicated. Why do we have hormones? Because if you're a multicellular organism, if you have more than two cells, those cells need to know how to communicate with one another so that everything's working together and in sync. And nature's figured out a really clever way to do that. And there's several ways, but hormones are one way.
It just seems like a sloppy way to communicate. Like I'm gonna wash you in a liquid, like a synaptic connection where there's, a fiber, a cable, and it's sending information from A to B feels like clean and directed and efficient. So why would we choose this bathing method?
I think because you can't have wires connecting every single cell to every single other cell.
Yeah, it would be like a scary motel where
Right.
you see the wires around the walls. Yeah.
Right. But we have this blood supply that feeds essential nutrients and oxygen to, all parts of our body. And so it's like hormones can just basically make use of what's already there in order to get your spleen talking to your heart, talking to your brain. Think of it like a broadcasting system. They're like the PA for the human body, and they go everywhere your blood goes, including your brain.
Which brings us back to the brain question. What are hormones doing up there?
The science is really, I'd say, mile one of the marathon. No, inch one.
Inch one. Wow.
We're using pretty archaic methods to understand the function of hormones in the brain. And a lot of it is correlational. Like most of the studies take large groups of people and take one snapshot of their brain and take one blood draw. But that snapshot in time, that's not how the endocrine system works. A fundamental feature is that it ebbs and flows over time. It is not static. In fact, all of its power comes from the dynamism of that system. Like my body doesn't care if I'm at 20 picograms per milliliter of estradiol. It cares that I came from 0 and I'm going to 200. So it's not the static level that matters, it's the change.
Oh.
And none of our experiments to date were capturing that change. But something happened in the field of neuroimaging about 15 years ago where somebody was like, wait a minute, I'm actually interested in how individuals change over time. This is a friend and collaborator at Stanford named Russ Poldrack, and he completed a project where he basically scanned himself over 100 times and just collected everything you could possibly collect. Like, how much caffeine did I have today? And how well did I sleep? And like, did I have an eczema flare-up? Like literally everything.
Oh my God, this is like my dream.
Yeah. And that study really launched this whole new way of thinking about the use of MRI to understand dynamics of the brain. And so my group, here we are sitting at UC Santa Barbara, and we're watching all of this great science unfold, and all of a sudden it unlocks this, it sort of solves this major problem for us because we're like, wait a minute, we can study an individual and track this change. And so I had this brilliant graduate student in the lab.
Yep.
Laura Pritschet.
Yeah, sorry, I'm going to modify my headphones a little.
And she was like, hey,
I have normal cycles. I have a summer to kill. I don't really have a life.
I volunteer to do this.
Emily is a philosopher and I am a country bumpkin. That's how I describe myself. And no better case subject than me.
So our girl Laura is actually Dr. Laura Pritschet now.
Now I'm in Philly for a postdoc.
But in 2018, she was a fresh-faced grad student in Emily's lab. She had just started studying neuroscience in her undergrad, and she was left feeling dissatisfied.
I noticed for like week after week after week, the papers we were having to read only included male animals. And I would pose this question of, why is this only males? And I would always get this response of, oh, well, females have an estrous cycle, akin to the human menstrual cycle. And that's just complicated and it's just a lot. And I was like, what the fuck? Like,
yeah,
you're studying basic features of the brain. You're also taking these findings and applying them to males and females. So the logic's not there. This doesn't make sense. And that seems pretty whack. At the same time, I remember my boyfriend at the time in college, his mom was going through menopause, and I loved her. And she would just talk to me a lot about how she would walk into a room and forget why she was there, where her keys were.
Oh, you put together like a human female going through menopause, and then at the same time you're seeing study after study after study doesn't have females in it. Like those two things connected for you?
Yes, exactly. Then that led me to go, okay, well, how do sex hormones influence the brain in ways that I can measure?
And then you were like, I know who can be the perfect study sample.
Yep.
Me.
Yeah, I was like, to answer these questions, I'll just roll up my sleeves. And that's, sort of how 28andMe was born.
Laura named her experiment based on the 28 days it roughly takes to complete a single menstrual cycle. And for each one of those days, she would
wake up,
go to the lab, spit in a vial.
I did saliva, and then I would go get my blood drawn.
Mario, the phlebotomist, would poke her in the arm.
We tried once to get my foot because I was a little too bruised up, and I almost kicked him in the face. Yeah, and then I would go straight to a 2-hour or so MRI.
They put her in a brain scanner and she had to lie totally still.
We 3D printed a foam head case custom to me, and I actually had them put sandbags on my legs and take straps and strap me in, almost like a straitjacket.
I can't believe that made you feel better.
Yeah, that's what I'm saying. I'm a weirdo.
So Laura was in there. She was under this like blanket of sandbags, and they would scan her entire brain while she was doing a series of mental exercises.
We did a resting state scan, meaning recording my brain as I'm letting my mind wander. And I would look at highly rewarding food for a block of, a minute. I would look at very neutral images like a Q-tip. And we looked at still images of porn. I remember there were like men taking selfies with a mirror, and I'm like, give me a romance novel. Like, this is not gonna do this for me. But I did that every day.
And Laura did this spit, stick, scan, again and again for a month.
The hardest part was halfway through, where you're like, I've done 15 days of this. Oh my God, there's 15 more?
And with every scan, they were taking a picture of what her brain looked like on each day of her cycle. And then with every task, they were looking at how her brain worked, literally how it was firing as she moved through that cycle.
Exactly.
Did you look at your data every day? Or did you wait till the end to look at your data?
Yeah, great question. I waited till the end. So we actually decided to start blind in the middle of a cycle so that I would eliminate as much bias as possible. And I also didn't even know where I was at in my cycle. And I remember I didn't even know when I was going to get my period, but I remember a graduate student had to come and give me like a tampon.
When it was all said and done, Laura and her team had all of these images of her brain. And then alongside that, they had what her hormones were doing at the time the images were taken. And when they put those two things together,
her data were beautiful. When she started to look at sort of relationships between that period when estradiol peaks right around the time of ovulation, she saw this massive increase in functional connectivity across most parts of the brain.
Wait, what is functional connectivity? What am I visualizing when you say that phrase?
This is really just a measure of brain regions that are talking to one another. All the bits of the brain are talking to one another in a way that's more congealed. So it's everything is just hyper connected. Imagine let's say we wrapped the brain in a string of Christmas tree lights. I don't know where this analogy is going, but we're going to try it.
Stay committed and keep going.
Okay. We're wrapping the brain in a string of Christmas tree lights, and when estradiol peaks, it's right around the time of ovulation.
Okay.
It's all the lights go on. The green lights are really connected to each other, and the red lights are all really connected to each other. It's they're all working in sync. And then to walk you through your menstrual cycle, right? Right after ovulation, you get this plummeting of estrogen, and progesterone starts to dominate the scene.
And during that moment, which is about a week before your period,
you start to see those lights dim a little bit. And it's not the brain activity is dimming or cognitive functions are dimming. It's just this shift in the basic connectivity structure of the brain.
It's kind of the structure of the brain is the same. It's just not as in sync.
But we also used a really high-resolution scan of the hippocampus. So this is the part of the brain that's, really important for learning and memory. What we discovered is that this region of the brain, and we can actually look at different subfields of the hippocampus. It's not actually one solid structure. It's got all of these little bits and bops. And that we could see these structures of the hippocampus actually grow and shrink along with the menstrual cycle. I mean,
Really?
On a rapid time
so
scale.
that one is actually physical.
That one is physical. It's morphological. It is a change that literally, the brain structure is changing across the cycle.
Really?
That's a thing people can wrap their head around.
My takeaway here is that these liquid chemicals in my body are washing my brain and changing it monthly, weekly, daily. But to be sure,
you need to essentially squash the endocrine system. And if you squash it, you don't allow those rhythmic endocrine changes to occur anymore, then let's see what happens.
So they basically do the entire experiment all over again. But this time, Laura...
I went to our student health center and I said, prescribe me the most common birth control packet you're giving the undergrads.
She went on a drug that suppressed progesterone levels by 97%.
The birth control basically wiped out the hormones in the back half of Laura's cycle, so that progesterone rise. And then she went back to the lab, spit stick scan, and...
the progesterone-dependent changes that we saw in the hippocampus across the cycle were completely obliterated.
So it did give you the chance to say, like, look at the data. These bumps we're seeing are because of estrogen and progesterone cycling.
Exactly, yeah.
Okay, so you're telling me I can keep telling people that at different points in your cycle, your brain changes.
Yes.
Wow.
But I think where we need to be careful is in the interpretation of that fact. So we don't know what it means in terms of behavior. So that's where we have to draw the line. It's like, I don't know if this is good or bad. It's just different.
Well, it's funny. It's like I can tell you what that feels like. In my body, it feels like you're making all these connections and you're going so fast and like the world is like a little brighter and I'm quicker. Like I'm like, give me an improv troupe. Like I will yes and the shit out of this show. You know what I'm saying? And then when what you're saying, the progesterone takes over and estrogen decreases, and when I'm like right before I'm bleeding, I'm like,
give me a sec.
Oh, like, yeah, like what was your name? Like, oh, yeah.
There were tears. I remember that was a note. I was crying in the parking lot for some reason.
As part of the study, Laura was tracking her mood each day.
Like I was seeing the negative affect rise with progesterone rising. So I was seeing it across multiple days. And I was like, wow, like this is real. And maybe for me and maybe not for the female across from me.
Laura and Emily did say they can't peg any particular person's mood or cognition to these hormone changes. I mean, the body is freaking complicated. Like estrogen affects dopamine. For me, that might feel really good to get that extra hit of dopamine. But if you're a person who already has a lot of dopamine, it could make you feel awful. So,
like, I think we still need the data to like understand how that is tied to those aspects of cognition.
If you're like a Molly brain, when you first hear this research, you're like, oh, wow, it's so cool. Like every day that I have had my cycle since doing this story, I'm like, what's my brain doing today? But it also feels like, oh my God, this is the exact thing that people have been saying for millennia. Women are hormonal. Women change. Unlike men, women aren't reliable.
When you like call somebody hormonal, it's like almost always directed at a woman, right? Like it's a pejorative, but like that belies the fact that like hormones are in all of us. These are ancient molecules. Every vertebrates have them. Like these are essential, and you know, men have them too.
But it sort of comes right from the fact of like ours females, however, you know, are changing on this 28-day cycle. It's like, I'm not saying like men don't have hormones, but I think there is a cycle that women are running through.
Right.
I'm not sure if you're about to tell me like, well, guess what? Men are going through a cycle too.
Yeah, guess what? Men are going through a cycle too.
Wait, really?
Yes.
That's right. We're not getting out of this episode without...
The trending thing is boy kibble, right?
A man. We're going inside the male cycle after the break.
Radiolab is supported by AT&T. Summer is great for many reasons. The best reason, our plans we made finally making it out of the group chat, because there's more time to fit everyone in. Whatever you've got in store this summer, capturing those memories is a must. And AT&T has your summer essential in the iPhone 17 Pro. Its center stage front camera auto-adjusts the frame to fit everyone into group selfies. You don't even have to turn your phone. No awkward cropping or asking strangers to take it. Just the perfect group selfie every time. And AT&T makes sharing those moments with everyone easy because you got to share the pic or it didn't happen, right? Right now at AT&T, ask how you can get an iPhone 17 Pro on them with eligible iPhone trade-in, any condition. Requires trade-in of iPhone 15 Plus or higher, excluding iPhone 16e and 17e. Requires eligible plan. Terms and restrictions apply, subject to change. Visit AT&T.com/iPhone or visit an AT&T store for details.
One of the reasons we did 28 and he, or just
is that what it was called? 28 and he?
Yeah.
Oh, that's hilarious.
Fun fact, this was actually Laura's then partner, now husband.
I met Laura first in intramural softball in graduate school.
Okay.
His name is Pavel.
Pavel Shapturenka. I am a scientist.
Shout out to Pavel.
The summer that we met, she had done prior that summer this study on herself, and I was just taken aback that someone would do that for science, would just stick themselves in a huge magnet for a whole month every day. I mean, immediately I was kind of like, wow, I'm in love, you know?
I've climbed the Eiffel Tower.
So when Laura said,
Hey, so how do you feel about climbing into the MRI?
Pavel said yes.
She would always be there by my side.
To your heart.
Every morning they'd get in the car,
I'd be pooling my saliva.
like collecting it in your mouth.
Yeah, yeah.
Like, don't talk, just gather spit.
That's right, yeah.
He'd walk into the lab, deposit his spit, and
Mario would come and take some blood.
I just love this character of Mario the phlebotomist. Then, just like Laura, he would lie in the scanner, still as can be. But for his experiment, he did double duty.
The first 15 days, we had a morning scan and a morning blood draw. And then 10 days into that 30-day period, we also started a 15-day nightly scanning.
Why were you getting scanned twice a day?
Whereas, you know, the main fluctuation of estrogen happens on a monthly time scale. Testosterone has sort of a daily rhythm, so it's diurnal. It's super high in the morning.
I did not know that. Okay, super high in the morning.
And then it drops by anywhere from 30 to 70% at night.
So for Pavel, we really kind of capitalized on this known circadian rhythm where testosterone and progesterone and estrogen are peaking in the morning, they're dipping in the evening. And we said, let's
Wait,
study
men have
him.
progesterone?
Oh, yeah.
Progesterone? Okay.
Yeah, they have all the bits and that we do at just at different concentrations. And these hormones cycle in men. And so we wanted to understand that. Like, is the male brain undergoing kind of a similar degree of change?
After all Pavel's data was collected, Emily and Laura had their team comb through it, and they saw.
The punchline is that essentially we see the exact same thing that we saw in Laura, that like when these hormones are peaking, you see the brain become like more interconnected with each other. And then when the hormones dip in the evening, the brain becomes less interconnected. And we see, the brain is pulsing on this 24-hour scale. So when hormones are high, it's a little bit bigger. At evening, it sort of like tightens up a little bit. And the crazy part is that we can literally see this, periodicity, this wave, if you will, happening every single day throughout the entire, he did 40 sessions across 30 days. So it's just this like beautiful rhythm that exists, and we can measure that.
That's crazy.
So it's like these hormones are having the same size effect, whether it's happening on a 24-hour time scale or across the 20-day menstrual cycle.
Huh. But wouldn't women also be doing this circadian?
Yes, that is true.
So we're getting circadian 24 and 28 across time.
That's right.
And men are more locked into the 24.
That's right.
I feel contradictory then, because somehow in you trying to be like, look, men are part of this equation too, it actually just leaves me feeling like, wow, my hormones are even more up and down than I thought. Yeah.
Meaning that,
Meaning
like
that
it's a
I'm
surprise that you have a circadian cycle on top of.
Yeah.
Like you're absolutely right in that this myth of female variability and this idea that we have this kind of like pesky
Emily said that
menstrual cycle.
even though females have these two cycles, studies have shown that they're not inherently more variable than males. In fact, it might be the opposite.
Here's where stuff gets, I think, funny. It's like, women have this menstrual cycle, and for most women, for most of our lives, it's as steady as the tides, right? Like, maybe until we start to get to menopause, or if there's like a reproductive condition, like short of that, like it is, this sort of rhythmic event. Again, it's this kind of predictable thing. That is not so true for male-dominated hormones like testosterone, which are famously capricious. So testosterone can like spike and dip, and it's like super responsive to social stimuli. So you can study this in animals who get in a fight, and you get these like testosterone surges, and then if they lose a fight, you get like testosterone suppression. It's true in humans who aren't even engaged in like, fist-to-fist combat. If they're just watching TV and their favorite team loses, you can see testosterone suppression.
But that's not happening with like estrogen?
Yeah, not as much. It's really, again, every sex has every hormone. It's just the proportions that are different. But in, testosterone, which is like on average higher in men, it's much more fickle.
Wow.
So it's just funny to me that women are the ones deemed as this like unknowable,
It turns out all of our brains are oscillating with these hormones. Whether it's monthly or daily or fickle or regular, all of us have estrogen and testosterone flowing in, and the brain gets bigger and more connected. And then estrogen and testosterone flow out, and the brain gets smaller and less connected.
Brains are built to change, they're built to learn, they're built to adapt. And here we have this mechanism, this hormonally mediated mechanism that's allowing our brains to do that. If brains did not change, that would be the pathology of interest.
But wait, can I just ask a question? I think my takeaway is that the brain is opening in some way when it's bigger or when it's firing in that stronger Christmas tree light, like analogy you gave, like when it's speaking to itself better, that it's opening.
Yeah. So like these estrogen rhythms are opening up these windows of enhanced neuroplasticity. And that's
neuroplasticity, you probably know this, is this idea that the brain is malleable. It's open to change. And Emily said all sex hormones, including estrogen, can go into the brain down to the level of the DNA and open it up.
So DNA is organized in this chromatin structure, right? So it's actually like pretty tight and closed up.
It's like wound tight, like everyone thinks of the helix, and then the helix is like
exactly
it's tight.
It's really tight, right?
Yeah.
But estrogen is one of the factors that can actually like loosen up the DNA. It just relaxes a little bit, and it can promote, the production of proteins, and then that's the pathway by which learning and all of these great things happen.
Okay.
But this paper that I just sent you...
I was like, I got it like 5 minutes before the interview, so I have no idea what it said.
I know.
Okay.
So this is work from Tally Barham, and oh my God, it's blowing my mind because this is what the study asked. What happens if during that brief, fleeting window where estrogen is flooding the system, your chromatin is all loosened up. It's like it's getting ready for its massage. It's on the table. It's warm. It's like, let's go. And then you introduce a severe stressor. Blasting loud music, you're sort of shaking the animal. You are introducing it to odors of its predator. If that happens during this period you create a PTSD-like phenotype in these animals.
Wow.
And it is long-lasting.
This study, which was done in both female and male mice, was an attempt to understand why some people record more trauma than others. And one of the takeaways was high estrogen plus stress can produce PTSD. Then they asked the question, okay, well, what happens in moments of low estrogen?
What she is suggesting in her data is that actually, if you look at the low estrogen periods of the female menstrual cycle, that they were immune to these stressors. Like they had almost like this armor on. What this work is suggesting, which is so profound, is that actually there may be sort of these protective mechanisms of having these beautiful but fleeting windows where you can drive plasticity, but then estrogen levels get a little bit lower and you are more resilient to these stressors. Again, pure speculation at this point because the science is so young.
I think for me, the thing with this study is that when I think about my period, the moments of high estrogen are the ones that I feel really good in, and the moments of low estrogen are the moments I want to get out of as fast as possible. But maybe at a deep biological level, those moments when we feel our worst, so for me during my period, maybe for you at the end of the day, those might be moments that are worth sitting in.
If you have really high connectivity between regions of your brain, that's really energy dependent.
That's Laura again.
You could be exhausted.
It is funny. Maybe part of what is opening up for me is like there's so much about, I just finished my period. There's like so much about it where you're like, but I'm like just thinking about it in a different way, like as it's like a way my body is like taking care of itself.
Yeah, I think that's a beautiful way of thinking about it. And I think, if I teach a class or guest lecture, I say, what comes to mind when I say estrogen? And it's like Zooey Deschanel's character in New Girl crying and, eating ice cream. And it's like, we can move from those stereotypes and be like, wow, hormones are just fucking powerful and they serve a purpose and they're neuroprotective.
And if anything, why are we trained to think of the cycle as a source of noise when in fact, I think it's a source of stability? Hormones guide behavior and they do so through this rhythmic action, whether it's across the circadian cycle for males and females or whether it's across something like the menstrual cycle for females.
Jeez, are you ever like, damn, our brains?
24 hours a day, it's going up and down, up and down. Then every other day, it's going up and down, up and down.
But I think it's like an organizing principle of the brain. It's like it's
Sounds
it's like,
tiring, but you're saying it's not.
I don't know. Like, is it tiring for the waves to happen on this rhythm? I don't know. Or is it like organizing the system in some really helpful way? I don't know. Those are the questions that I want to dig into that, we have just scratched the surface on scientifically.
So what just the fact that you could even suggest something like, is it organizing us in a certain way? I'm like, ooh, why did you choose the verb organizing? Why would brain changes be organizational?
The brain likes prediction. It likes rhythm. It likes,
it likes rhythm.
It's like providing a scaffolding or a structure. It's the same thing like if you have kids and you let them just there's no rules in the house and they can put themselves to bed whenever they want or they can eat whatever they want. It is high chaos in the house and nobody's happy and nobody functions well. But you put a little bit of structure, you put a little organizational structure, and then all of a sudden shit flows better. And maybe that's what hormones are doing. It's laying down these fundamental rules, these organizing principles for the brain that can that help it function at its most, at its highest level. I don't know. I'm totally speculating here, but
yeah.
But now we get to at least ask the question of is that pulse doing anything that the brain likes or that helps us in some way?
Yeah. Wow. That's a cool word, pulse. Like brain pulse. It's it's working out up there.
Yeah, it's like the heartbeat of something, right? It's like the vital sign. Like
Yeah.
it's like you think of like the cha-chunk, cha-chunk, cha-chunk of like the heartbeat monitor. Like maybe this is the endocrine system. It's like it's pulsing on these different rhythms, and then it's creating these echoes throughout the rest of the body that's like, oh, cool, like here's the rhythm we get to dance to. And that's what I mean when I am thinking about this sort of organizational framework. It's like I think it's creating that rhythm for then the whole body to get in sync to.
I think I'm having this question of the brain is such a regal and like commanding object, right? Like you kind of know how much work it's doing in your body. Even though it's part of you, it kind of feels like other. Like there's a way in which it just has it's all powerful. And so then when I hear something about the brain changes, I'm like immediately like, wow, like awestruck.
Yeah. Oh my God. I think that idea that the brain is like this regal thing is a myth. I actually think it's an organ like every other part of our body. Like I think the way we can show that hormones influence aspects of the brain suggests that, I don't know, we're all just kind of these like, big buckets of chemicals walking around and we think we have control, but like, no, we don't.
Really?
Like I yelled at that person because I'm hangry and I don't even know if I buy into free will, if I'm being totally honest. I don't know. I mean, I think that there's ways we can gain free will, but like by and large, we are also just like big biological sacks of stuff. And
I'm
anyway,
hoping that I'm a big biological sack, but if I know that, if I say it out loud, then I could maybe do a little bit more with the sack. Like I could push it to the left and push it to the right, even if only an inch.
Maybe.
I hope. That's my wish.
I do think an understanding of the system allows us to control it. In fact, I was just on a call earlier this week there's this incredible researcher out of Caltech, and he's developing continuous hormone monitors. So, we have the glucose monitor where we can track. Yes. And now they're starting to develop technology where either from sweat, which seems difficult, but even in like interstitial fluid, you can create a glucose-like monitor that can just give us this kind of constant readout of hormones. I mean, imagine if we could get like a second by second or even just hour by hour readout. We can just watch and observe and see the patterns play out. But that's so huge. I mean, think about the images of Pluto that we had 100 years ago, where it's this like grainy little blip in the sky, and now we can see the individual like craters and this idea of let there be light, like being able to see a phenomenon in incredible detail is the start where all of the breakthroughs happen.
This episode was produced by Mona Madgavkar and me, Molly Webster. It was fact-checked by Diane Kelly. I want to thank Soren Wheeler, Pavel Shapturenka, Emily Jacobs, and Laura Pritschet. Emily hangs out at the University of California, Santa Barbara. You can find Laura and Pavel at the University of Pennsylvania in Philadelphia. And you can also find all of Laura and Pavel's data online. Go to openneuro.org. That's openneuro.org. Props to Laura for making all of her data public. Also, a huge shout out to Catherine Woolley, whose original research on sex hormones and the brain was foundational to all the stuff we're talking about today. If you find yourself with some spare time, go to radiolab.org/thelab and sign up for our members only access. You'll get ad-free listening, special content. It's fun over there. And that's it. I'm Molly Webster. This is Radiolab. And the next time I see you, I'm going to ask, where are you at in your cycle?
Hi, I'm Gabby. I'm from the Bay Area, California, and here are the staff credits. Radiolab is hosted by Lulu Miller and Latif Nasser. Soren Wheeler is our executive editor. Sarah Sandbach is our executive director. Our managing editor is Pat Walters. Dylan Keefe is our director of sound design. Our staff includes Jeremy Bloom, W. Harry Fortuna, David Gable, Maria Paz Gutierrez, Sindhu Nainasambandan, Matt Keelty, Mona Madgavkar, Annie McEwen, Alex Neeson, Sarah Kari, Natalia Ramirez, Rebecca Rand, Joanna Strogatz, Anissa Vitsa, Arian Wack, Molly Webster, and Jessica Young, with help from Gabby Santos and Maya Appleby Melamed. Our fact-checkers are Diane Kelly, Emily Krieger, Natalie Middleton, Angeli Mercado, and Sophie Samai.
Hi, I'm Aubrey, calling from Salt Lake City, Utah. Leadership support for Radiolab's science programming is provided by the Simons Foundation and the John Templeton Foundation. Foundational support for Radiolab was provided by the Alfred P. Sloan Foundation.